Hello and welcome to my video on how to solve inequalities and specifically how to write them as combined inequalities. So to start with, we're going to look at a linear inequality. So let's say x plus 4 is greater than 7. And all we really want to do is the same way that you would solve this if this was an equal to instead of a greater than. We're going to move the 4 over. X is greater than 7 minus 4 is 3. And now we're looking at a just quick number line to show which values we're looking at. Plot my 0, 1, 2, 3. It's a greater than, not a greater than or equal to. So this will be an open dot. And then x is greater than, so I want all of the numbers greater than that. And let's go ahead and do that in a nice little red arrow if we can. If you'd prefer, you can just draw a dot below with an arrow. That way you don't have to color over your line. Similarly, we can talk about all sorts of other linear inequalities. Let's say x minus 5 is greater than negative 3. So, in the same way, x is greater than, add 5 to both sides, 2. So, a quick number line will let you plot your values, 0, 1, 2, and we'll put an open dot with an arrow going out. Now, the trouble that a lot of people come into is what happens when you have more than just one x value. Specifically, we're going to look at some parabolas. But first, we need to be able to factor parabolas. There's some other videos of that online as well. So I'm going to go fairly quickly through some of this work, but let's start with a parabola. How about x squared minus 2x minus 3, and we'll say that that's greater than or equal to 0. In other words, I want to know where this expression will be greater than 0. Now, you can either factor this, or you could use the quadratic formula to find which values of x will work. But I'm just going to quickly factor this. That will factor into x minus 3 and x plus 1 greater than or equal to 0. So now what we need to do is we need to check where both of these expressions are greater than or equal to 0. So just like you would when if you were finding this equal to 0, you're going to take each expression and set it greater than or equal to 0. Solve each expression. X is greater than or equal to 3. X is greater than or equal to negative 1. Okay? And it seems here like we could just take one of these values, because anything greater than or equal to negative 1 will also be greater than or equal to, anything greater than or equal to 3 will also be greater than or equal to negative 1. But here's what we need to be careful of. There are some values that won't work in this combination. To find those, we're going to plot these two on the same number line. And I'm going to plot this one in red, and I'll plot this one in blue. So, we've got our number line. Drop my 0. And I need something from negative 1 and something from 1, 2, and 3. So, all of my values where x is greater than 3. And all of my values where x is greater than negative 1. And here's what we're looking for. If these two things are going to multiply to be something greater than 0, they either need to be both positive or both negative. Right now, these arrows represent where these two expressions are positive. So where there is no arrow for that color, you have where that expression is negative. So over here, our red expression is negative. Our blue expression is negative, which will make the multiplication positive. Here, our red expression is negative. Our blue expression is positive, which will give us a negative. And out here, again, we now have the arrow, so we have a positive for our red, again a positive for our blue, which gives us a positive. So the only numbers that will make this expression greater than or equal to 0, in other words, a positive, are numbers where x is less than or equal to -1. That's a little counterintuitive from what we solved. Or when x is greater than or equal to 3. I'm going to quickly plot another one. I'm going to skip the factoring portion, but I want you to have a couple of examples. So let's say x plus 5 and x minus 4. And let's say we want that to be less than 0. So we want either a positive and a negative, or a negative and a positive, just so we can look ahead. So again, I'm going to solve for each of these less than 0. X plus 5 is less than 0. X minus 4 less than 0. So x is less than -5, or x is less than +4. And again, we're going to plot these on a number line. There we go. And let's go ahead and do this one in red. And this one will be in blue again. So x is less than 4. Less than, not equal to, so I have an open dot at 4. And an arrow going all the way out this way. Notice now my arrow represents where this expression is a negative, not a positive anymore. And an arrow going out that way. For my x is less than -5. And now, just like I did over here, I'm going to draw some lines at those specific values. I'm sorry, this should be an open dot, not a closed dot. My apologies. Again, drawing some lines at those specific values that I found. And now I'm going to evaluate. So I have an arrow here and an arrow here. Notice, again, these arrows tell me where these expressions are less than 0 or where they are negative. So I have a negative value for my red, a negative value for my blue, which gives me a positive value down here when I multiply them together. Here I have a negative value for my red, a positive value for my blue, so when I multiply them together, I will get a negative. And lastly, a positive red out there, a positive blue for a positive. Okay, so the only space where this multiplication will come out to be a negative, in other words less than 0, is between -5 and +4. So -5 is our bottom end, can't be equal to, just less than, x, which is less than +4. You'll notice that here I combined my two inequalities, and here I left them separate. That's because if you tried to write this as one inequality, saying maybe -1 is greater than or equal to x, I just flipped this around, which is greater than or equal to 3. This implies that -1 is greater than or equal to 3, which is not true. -1 is not greater than or equal to 3. So this statement can't be written. We have to write it as an or statement when they're separated by something. We can write it as an and statement when it's contained all in one space. Thank you for watching, and look out for more videos.